This is the section that's extremely important. That's why I'm getting nasty. The other ones are simplistic, and most people get them for the most part. This one is a little strange. First thing, we need to talk about our reference angles. Reference angles has two pieces to it. Piece number one, location. And piece number two, measure of acute. Is it ACC or AC?
DC.
Actually, I think it's just AC. Acute angle. Now these measures of acute angles, remember acute angles have to be measures that are less than 90. We're going to be talking about angles that are greater than 90, but we're going to bring them back into an acute land. But to bring them back into an acute type of measurement, we also have to know where they are located. Are they in the first quadrant? Are they in the second quadrant, third, or fourth? What?
Wait, you said we have to bring them back. How are we forcing them?
We're getting there. I'm teaching it. Give me a chance. I can talk to you that way. I'm getting there. It's part of the lesson. There's the blue marker.
Why do you use those black things?
They're the ones that this thing reads.
And why do you have to throw it?
Because I like to throw in things.
Well, what if it misses?
It did.
Yeah,
I'll pick it up.
precisely.
I'll pick it up. So one thing we have to understand is locations are going to determine a lot of things. So let's go back to our unit circle. If you're in this quadrant, let's talk about one function at a time. If you're in quadrant 1, and we're talking about the sine function, what kind of sign does the sign have? As in S-I-G-N rather than S-I-N-E. It's positive.
Yeah.
So in the first quadrant, sine's positive. What about cosine? Positive. Tangent. Positive. That makes sense because all the numbers are positive there. Now, if we move over into the second quadrant, just look at the sign. What is the sign? Well, sine is the second quadrant, or second coordinate.
is positive.
And it's positive because the y is positive over here. So sine is positive in the second quadrant. What about cosine?
Negative.
It's negative. Tangent?
Tangent negative.
Negative. So the only thing that's positive in this quadrant is sine. So I'll put a little s there for now. What if I come down here to the third quadrant?
They're all negative.
They're not all negative.
Tangent is positive.
Sine is negative because we're y negative. Cosine is negative because the x is negative. But tangent is y over x, and a negative divided by negative is a positive. So tangent's perfectly fine in this quadrant. It's positive in that quadrant. Everybody else is negative. Now, when I say tangent is positive, so is cotangent, because it's just the reciprocal. All right, come over here to the fourth quadrant
Would cosecant be the same for 2?
for sine.
Yeah.
Cosecant would be positive in this
in-
quadrant.
Okay.
Yeah.
So I closed it out.
If you're in the fourth quadrant, your x value is positive, so cosine is positive. Your y value is negative, so sine is
Negative.
and tangent, because it's a mixture, is also going to be negative. So the only one positive here is cosine. So you get this thing that says, all students take calculus.
Nah.
Yeah, I remember that.
Which
I
I
do
wish.
remember that.
So all of them are positive in the first quadrant. Only sine and cosecant are positive in the second quadrant. Only tangent and cotangent are positive in the third quadrant. And only cosine and secant are positive in the fourth quadrant. All right. So this is the location thing. It's going to tell us what the sign of the function is going to be. And then we're going to use the measure of an acute angle to calculate out what the thing is going to equal to begin with. So for instance, if I have the sine of 3 pi over 4, highly suggest you get used to drawing pictures. Where is 3 pi over 4? Second quadrant. So you have this angle over here. Draw a triangle, but it has to come down to the x-axis. Never ever draw your triangles to the y-axis. None of them ever exist that way. Everything drops to the x-axis. If this is 3 pi over 4, what is the measure of the angle coming to the x-axis?
1 pi over 4.
Just a regular pi over 4. This angle here is called a reference angle. Because pi over 4 technically is in the first quadrant, but we're pushing it into the second quadrant. All right, so this is equal to the sine of pi over 4. That gives us our measure of an acute angle. The next thing we have to worry about is, where's it at? Well, this is a sine function in the second quadrant, so the sign is
Positive.
So I'm going to emphasize this by putting a positive there.
Alright.
So the answer to the sine of 3 pi over 4 is square root of 2 over 2. Or 1 over square root
Why,
of 2.
how did you
How did I do what?
How did you get square root of 2 over 2?
Oh! Special triangle.
You didn't, yeah, you didn't teach us this.
Yes, I did. This is
You taught us special triangles. but you
45 degrees, which is the same thing as pi over 4. This is 1, 1, square root of 2. The sine is opposite over hypotenuse. This is the same thing as 1 over square root of 2.
Is it literally equal to one another? The sine of 3 is pi over 4. Is it literally equal to positive sine pi over 4?
That's the beauty of reference angles.
But they have totally different angles.
Right, but they're equal to the same value. How do
I'm
I?
confused, yeah, with
Well, I mean, I'm drawing the triangle, right?
Yeah,
Right.
you are.
So the triangle determines what it's equal to as a value. The only thing I'm curious about, the only thing that would change is that positive sign. It could
How did
be,
you get the reference angle again?
well, if this is 3 pi over 4, what's left coming down to the x-axis?
Pi
Pi
over 4, gotcha.
Okay.
And the 1 over the...
Well, 1 over the square root of 2 is, opposite over hypotenuse. Well, technically, you're supposed to write a square root of 2 over 2, but 1 over square root of 2 is fine. 1 over square root of 2 is nice because if you want to change this into cosecant, you just flip it and square root
But
of 2.
what can you just I mean, if you write it like a square root over 2 over 2, is that gonna be wrong? I mean, do you have to write it like that?
Either one. I don't care which way you write it. Some people, they get fussy with radicals in the bottom. I don't. Not when you get higher level, it doesn't really matter.
So it only counts for the dropping down of the triangle itself, right?
No, that counts for the...
No, I mean like the equaling of the two things.
Everything is equal as long as I have that sign correct.
So if it was let's say 5 pi over 4,
Uh-huh.
it would be a negative sign of...
Well, hold on. Cosine of 5 pi over 4. Why not?
Okay.
So, draw a picture. 5 pi over 4 is going to be in what quadrant? Third. So you go out here someplace. There's your angle. And this measure is 5 pi over 4. Now, coming back to the x-axis,
It's pi over 4.
that's just regular old pi over 4. So this is considered a reference angle. It is pi over 4 in the third quadrant. Alright. We draw a triangle with this. This is called a reference triangle in the right quadrant. If you want, you can separate your picture over here, but I usually just draw it right in the picture. What is the measure of this side? Well, it's 1. This one is 1, and this one is square root of 2. I'm going to show you a neat little trick after a couple of these, but not right away. So this is going to equal cosine of our reference angle, which is pi over 4, but we're in the third quadrant.
Negative.
So it's got to be negative because the only thing positive there is
Tangent.
tangent. So this is negative cosine of pi over 4.
I think we had a couple of other problems like that.
So this is going to equal negative 1 over square root of 2, negative square root of 2 over 2, whichever one you like. That's it. Done. These are easy. Supposedly.
So, does it, even if you do a tangent and say you did tangent 3 pi over 4, would it still be in the second quadrant?
Yes.
Okay.
The angle is where tells you where the location is. The function will tell you if it's positive or negative.
And what you have to do to it,
And what you have to do to it, yeah. Opposite of
Will you
yours.
only ever give us special triangles, or will you give us?
Well, the point is to give you special triangles to let you evaluate it by hand. I don't want you doing it by calculator because you can type this into a calculator and come up with an answer, but it's not going to be 1 over square root of 2. It'll be like 0.717 something or other.
Okay, so because like tangent's only positive in the third quadrant. If it's in the second quadrant, it's negative, right?
Mm-hmm.
But the values you have, if one of them cancels out with the other, well,
Okay,
it's still
now you confuse me. What do you mean cancel out with another?
like if the values itself, like if it was like 1 over 1 in a way.
The only way it would be 1 over 1 is tangent of 45.
Yeah, that's what I'm saying.
So it'd be 1.
Would it be negative though, since
If tangent was in the second quadrant, if it was tangent of 3 pi over 4, it'd be negative 1.
Okay.
If it was tangent of 5 pi over 4, it would be positive 1. So far, so good?
Wouldn't you put it as negative square root of 2 over 2?
You can. Yeah, I mean, this is exactly the same as negative square root of 2 over 2. After you rationalize it. But if you want to leave it as negative 1 over square root of 2, that's perfectly fine. Just got to be careful. My answers are usually rationalized, unfortunately. How about you add on a page? Wake up. No, darn it. Oh well. Find me that one. Who's one of our homework problems? Cosecant of negative 3 pi over 4. Alright, draw a picture.
Negative 3 pi?
Yeah, why not?
Is it gonna be in
I don't know where it's going to be.
the third?
I'm guessing.
I'm saying it's third.
Guessing's bad. You're right. What? Do I know sign language?
I'm doing this very simplistic.
Third.
Oh, I see. Third quadrant, right?
Oh, whoa.
Wait, hold on, no, don't.
No, I take that back.
Yeah.
It's in the third quadrant?
Why? It's pi over 4,
Yeah.
and it's 4
Oh,
pieces in the bottom, and it's negative. You have to go backwards and back off 1. Third quadrant. Location is more important than the triangle itself. Because that'll determine whether it's
So I
positive
change
or
my
negative.
answer.
Yeah, it changes your answer completely.
So then would the answer be the same thing, the negative square root of 2 over 2?
Nope.
Can an angle be negative?
Yes, that is a negative angle.
Well, I mean, like, you know what I mean?
Could that be negative?
What do you want to know from this? It's location.
Wait, is it?
Everything.
Yeah.
Would it be negative?
Reference angles are always positive. They're assumed to be first quadrant angles, but you push them into another quadrant. The answer's negative. The angle's negative.
I'm talking about what is square root of 2? It is.
Never.
Why?
Because it's
Oh,
a triangle.
It's a radius of a circle, and radiuses of circles can't be negative. Remember, it's on a unit circle, or some circle.
Okay, what if it gets out of
negative square root of
What's that?
What if it gets out of the circle?
Well, then you
Well,
should-
that's what I'm saying. It's a radius of a circle. Remember when we defined trigonometry on a triangle, I just made the circle bigger.
you should
and then we
put
use
negative
triangles
1
to
and
come back to
negative
it.
1. You need to put negative 1.
I didn't label it that way. We
This
could.
is a triangle.
We could, but I'm not doing it right now.
Why?
It's an upper level thought
That's what I
process.
had.
That's
That's
fine. You
what
could do that. So this is equal to. Now, what is cosecant? It's a sign flipped over, so it's hypotenuse over opposite. So if you look at this angle, the hypotenuse is square root of 2. The opposite is 1. So this is square root of 2 over 1. But it's in the third quadrant, so what sign does it get? Negative. So this is literally just negative square roots of 2.
Yay! So if you wanted to write it as a sign, what would
If I wanted to write it as a sign,
be? I've been wondering. So you wouldn't flip the numbers inside.
heck no. It is the reciprocal of its ratio, not its insides.
Can you just put like that little negative?
Is it really?
What? Nah, not even close.
Oh.
I have time.
I'll go work, man.
I have to work today.
I'm off today, I couldn't get out.
I have to work today too.
How about,
Dang. Gotta figure this out all day.
tangent of 17 pi over 6?
Oh, let's figure, you wanna figure this out?
I want you to do it. 17 pi over 6. I'll give you the special triangle.
Oh, I know it.
for now.
Would you?
Depends on how I write my answers on my multiple choice, which will be next class. What quadrant are we in?
Second.
Second, because if you wrap around, this would be 12, this would be 18, and you have to
Go back.
back off 1. So your angle's here. The reference angle is pi over 6. So this side is 1, this side is 2, this side is square root of 3. And the tangent is opposite over adjacent. So it's equal to 1 over the square root of 3, but
Negative.
location is second quadrant, tangent is
Negative.
negative.
I got it right.
Oh wait, I didn't get it right, never mind. I was close.
So sad. Now, there is another way of doing this where you don't have to remember all students take calculus for this type of problem. You could label the numbers with their proper signs. 2 has to be positive, it's a radius of a circle. 1 is positive because you're going up, but square root of 3 is
Negative.
negative. And if you do that, what happens is you get the same answer. Without memorizing all students take calculus, you would just go, well, tangent is equal to 1 over negative square root of 3, and therefore it's negative. You could have done that on all of these. Like this one over here, it's going down 1 and left 1, so they both become negative. When you do cosecant, you're going to get negative 1 over square root of 2. If you did tangent on this, you'd get negative 1 over.
Isn't the hypotenuse always positive?
Hypotenuse has to be positive, no matter what. So the only thing that would be negative is the legs. So that's a neat little trick if you want to play it, but not super necessary. All right, quiz time.
No, I don't.
Fine.